As our planet warms, alarming changes are being recorded in Alaska. Dr. Marisa Repasch, a UNM professor in the Earth Planetary Science Department, has been conducting research in Alaska over the past few summers to record an increasing amount of carbon export from an Arctic river.
Our first field campaign was in the summer of 2022, and we rafted down a river called the Canning River. And that river flows from the Brooks Range across the North Slope all the way to the Beaufort Sea. My research focuses on understanding how climate change is impacting the Arctic landscape. I try to understand the dynamics of the landscape, mostly how rivers move through the landscape, how water flowing through rivers changes over time, and how that influences the carbon cycle. One of the motivations for doing this research is understanding what's going to happen to the vast amount of carbon that's stored in Arctic permafrost soils. In the summers of 2023 and 2024, we did additional field campaigns where we flew in through a fixed-wing airplane and also had helicopter support for some of our work. We were able to collect samples from different parts of this river system. We collect primarily suspended sediment samples for my research. And when I say suspended sediment, this is really just particulate matter and sediment and soil that's been eroded into the river and is transported by the water. And so when we collect samples of suspended sediment, we need to either wade into the river and collect water samples, or we take a boat out on the river to collect the water samples depending on the conditions. And then we have to filter those water samples in the field to separate out the suspended sediment and the particulate organic carbon from the rest of the water. We usually collect 20 liters of water and spend several hours filtering it later in the day. Pouring in the Van Dorn water sampler. It was about a meter under the water surface, and there's a lot of particulate matter in there. All being eroded off of these tumbling turf blocks. So this research was part of an NSF postdoctoral fellowship. So it was a project that I developed myself, and I developed it because I was really motivated to understand what's happening in the Arctic. Climate change is influencing the Arctic more so than anywhere else on the planet. The Arctic is warming 4 times faster than the rest of the world on average. And so I was really interested in what that climate change is doing to the rivers there in terms of how much water is flowing in them, and also what is happening to the carbon that's stored in soils that were previously frozen. These are soils that are really carbon rich and that have been frozen since the last glacial maximum. As we lose sea ice and as we warm up the ocean waters, that drives more evaporation and it actually causes more thunderstorms to happen. And thunderstorms traditionally have not been very common in the Arctic. And so what we're seeing is very frequent thunderstorms in the Arctic that drive a lot of runoff. And when I say runoff, I mean just more water flowing in the rivers. And because the ground is frozen, that water doesn't infiltrate in the soils like it does in other parts of the world. And so the water runs off of the landscape really quickly and delivers a lot of carbon off the landscape with it. And so if we keep increasing the number of thunderstorms happening in the Arctic, more carbon will be exported to the ocean.
Once this carbon enters the ocean, it eventually makes its way back into the atmosphere, creating a positive feedback loop of rapid warming in the Arctic. However, there are solutions to this issue.
If we can do everything we can to stop increasing the amount of carbon that's in the atmosphere, that will slow down climate change. As a country, I think we really need to invest in renewable energy to get away from fossil fuels, which emit carbon into the atmosphere. When you're in places on the North Slope where there are no roads, there's really no airstrips. We fly there on small airplanes, but we just land on gravel or open grassland. And so it feels like a place that is relatively untouched by humans, which is amazing. And you get to interact with wildlife. We've seen grizzly bears and musk ox and caribou and lots of birds. It's really special. It's also great for research because we know that we're studying natural processes that have not been impacted by humans. When we study places like the Rio Grande and Albuquerque, there are a lot of human impacts that have altered that system.
The next steps in furthering Dr. Repasch's research is the installation of satellite monitoring stations, such as Planet Lab satellites.
Field work is a lot of work and time, and it's expensive to get out there. And so if we could make our research processes more efficient, that's what we would like to do. So satellites are constantly revolving around our planet every day and taking images. And so we can potentially utilize those images to see how the rivers are changing over time and how much sediment and carbon is exported by the rivers. And you can really see that in the color of the river water. So we can take satellite imagery and use the different combinations of wavelengths that are recorded by the satellites to try to calibrate the samples that we collect in the field to a color that's seen by the satellite. And then we can use algorithms to try to track how that color changes over time and what that means for sediment and carbon.